Okay, boys and girls, welcome to day 7 of our summer HEOP program in the science class. Today we are going to start chapter 3, which is all about sensation and perception. So, this is the first section of chapter 3 is entitled How the Physical World Relates to the Psychological World. And so, what we're going to do is talk about um, some of the interactions between our actual senses, our sight, our sound, our hearing, taste, smell, and touch, um, and what's going on up here that allows us to perceive it. Sensation is one thing. All right, this is the nerve endings that are being stimulated by light or sound or taste. Okay, the perception of that sensation is a different thing. That is all up in your brain. So, essentially, this section is divided into 3 questions. All right. And the first of those questions is what we call the detection question. All right. This is really the physiological, all right, the physical world aspect of this. And it's concerned with the limits of our ability to detect very faint signals. All right. So, questions that you might ask are in regard to the detection question are things like, how intense does a light have to be for us to see it? How loud does a sound have to be for us to hear it? Now, one of the things you have to realize is that our reality, each of us individually, not as a species, but individually, our reality is based on how we gather information, and those are our senses. But it's also based on how we interpret those questions, all right, which is our perception. Okay, so reality is based on how we gather information and interpret information about the world around us. And our view of the world is subjective, all right? And it's constructed by our individual brains based on assumptions that are both built in and that develop over time with our experiences. So, when I say, how intense does a light have to be for us to see it? It depends. Are you looking for it, or is it just kind of in the background? All right. How loud does the sound have to be for us to hear it? All right. There are background noises all the time. You ever sit under a fluorescent light bulb in a school? All right. If it's really, really quiet, you can actually hear the noise, the humming that the light bulbs make. But while you're sitting in class listening to me or any other teacher for that matter, you don't hear that sound at all. You kind of tune it out. All right. And see, this is what the detection question is really all about. Are you paying attention to what's going on? You're sensing a lot of things, but are you perceiving the same things? All right. And that really is where we're going to start with this. All right. So the detection question is concerned with the limits of our ability to detect very faint signals. All right. So if you're looking for a light, how intense does that light have to be in order for you to see it? If you're listening for a sound, how loud does it have to be for us to hear it? Okay. Now, the detection question comes down to what we call the theoretical absolute threshold. And what this means is that people should respond no to any stimulus with less than a certain amount of energy, and yes to a stimulus that has more than that amount of energy. All right. So, what light is measured in units called lumens, or sometimes candles. All right. And so if the absolute threshold is 100 lumens to see a light, that's very bright, by the way, but just let's say we'll make it more realistic. Let's say it's 4 lumens, all right, in order to see a light. What that means is that if you set the light at 1 lumen, your patient will not see it. 2 lumens, no see it. 3 lumens, no see it. 4 lumens, maybe. All right, 5 lumens, he sees it. 6, 7, 8, 9, all the way up to 100, you see it. And so if you were to draw a graph that represented this, and you put over here the percent of yes responses, all right, and then and so it's 100% up here and 0% down here. What you would expect to see in terms of the graph is something that looks like this. All right, we're going to answer no, 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 and then all of a sudden it's going to shoot vertically upward to 100%, and then yes, 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 yes. All right, and so whoops. Oh, come on now. Where am I? There we are. And so why am I going backwards? That's a new one. All right. So this point right here is the theoretical absolute threshold. Okay. That's this point right there. Okay. And so anywhere below this threshold, the answer is no. So 0%. Anywhere above this threshold, the answer is yes. All right, and that's why we have 100% response up here. Now, in reality, there was when this experiment was actually conducted, there was no abrupt transition point. There wasn't that vertical line in the graph. All right, and so what happens is that in reality, the percentage of time that a person says yes gradually increases as the amount of energy in the stimulus increases. And so it's not a straight vertical line, it's a different kind of picture. Okay. So rather than the absolute, the theoretical absolute threshold, we use instead what's known as a statistically defined absolute threshold. And what this is defined as is the minimum amount of energy in a sensory stimulus detected 50% of the time. Okay. Now, this is a statistical definition because the experimental results that we just talked about indicated that there was really no abrupt transition from responding no to responding yes. All right. It wasn't an all or nothing thing. And so in reality, the graph that we just drew doesn't look like what we said earlier. We have 0 and 100, and this is the percent yes answers again. But over here, what happens is that there's more of an S curve. All right, it looks something like this. And there's a point right here, and that's the 50% mark. And this point right here on the x-axis, this is what we call the statistically defined threshold, absolute threshold. All right. And so essentially what it means is that half of the folks, or the half of the time, they say yes for a certain stimulus, and that means that that's the threshold that we use. All right. So if a person only answers yes 48% of the time, all right, that's below the threshold. Okay. If he answers yes 51% of the time for a certain stimulus, that is above the threshold. Okay. All right. So that leads us to our next issue. All right. The statistical definition of absolute threshold leads to questions about the definition of what we call subliminal processes. In other words, below the threshold. That's what the word subliminal means, below the threshold. Now, what this means is that sometimes there are stimuli out there that you know are there, but people don't seem to be able to detect them. Okay. A very dim light, all right, that some people can see, but most people can't. Um, a really good example, in my opinion, is mosquitoes and flies. All right. Now, for me, if a mosquito lands on my arm or my neck or my leg, I feel it almost right away. But there are some people who seem to, the bugs just kind of land on them and they just kind of move around, and the person doesn't seem to sense that they're there. All right. What that means is that the bug has not reached that level of uh, stimulus that the person actually perceives it. So I guess what I'm saying is that my sensation is more powerful than others. But the where does this lead? What are the definitions? What is a subliminal stimulus? In other words, something below the that threshold. Um, so if I torture my daughter and I do this, all right, she can't feel that unless I poke her. All right, and then she feels it. But even if I just touched her, all right, would she know I was there? Yeah, maybe, maybe not. All right, maybe, maybe not. All right, at a certain point she will if I continue to increase the stimulus, but it doesn't necessarily work that way. Now, if she's completely wrapped up in a video game, that level of threshold may drop. All right, and I may be able to just stick her with a pen or hit her with a tennis ball, and she wouldn't know because she'd be staring at that stupid screen like it was Jesus come again. Now, the fact is that this subliminal stimulus occurs all the time. All right, we just don't realize it. We sense it, but we don't perceive it. Now, I just want to be very clear. Subliminal is not the same as subconscious. Your subconscious is thought processes that occur without you uh, being aware that they're occurring. All right. We talked about the need for sleep in the last video. That is subconscious when your dreams and other things are putting, you're putting pieces of a puzzle together, and you wake up in the morning and you know the answer to a problem that you didn't know when you went to bed the night before. All right. Back in the 1950s, by the way, there were uh, movie theaters and movie producers tried to slip ads in, and they'd show a can of Coca-Cola or a bucket of popcorn just for like a tenth of a second, and they were trying to make people hungry and make people thirsty and make them go to the concession stands and buy it. There's no evidence that it worked. Now, this is a YouTube video on the threshold of sensation. All right. The guy who does this video uses sound. All right. Interestingly enough, he uses Darth Vader's theme song, which I think is just awesome. But pause this video and go and watch that one using the PowerPoint in Canvas, or wait till this is over and then go back and watch it. All right. But it's a good video that talks well about the detection question. Okay. All right. Now, the last part of the detection question is what we call signal detection theory. All right. And this is a theory that assumes that the detection of faint sensory stimuli, so really low stimuli, depends not only upon a person's physiological sensitivity to stimuli, but also his decision criteria for detection. All right, and that's based on non-sensory factors. What the hell does that all mean? Well, it means that if you hear background noise, all right, you may choose to respond to it or you may not, based on what's going on in your mind. It doesn't, you still hear it, but you choose to respond or not. Now, when the triplets were little, And even really to this day, if one of them rolls over in bed or gets out of bed, and goes to the bathroom or something, gets a drink of water in the middle of the night, I hear it immediately and I am up. All right, I'm attuned to that. All right, and so that's my physiological sensitivity is my hearing, but my criteria for detection at in the dark of night is very low. All right, if I hear a noise, I'm going to wake up and look for it. However, I will also tell you that if I'm sitting here grading papers or whatever I'm doing, and the two boys start beating the crap out of each other in the next room, I tune that right out because they do it so often. I don't care. All right, it doesn't matter unless they're interrupting my work. It's not really something that I worry about. And so, even though I hear both of those stimuli, the dark at night creeping down the hallway thing and the full blown war that's going on the couch next door, I'm not going to respond to one, but I will respond to the other, and that's based on my criteria for detection. Now, signal detection theory is has been designed as a game. All right. For those of you who studied or will study advanced biology, you'll know that game theory, and I'm not talking about the game of Operation or Sorry or Life or Guess Who. All right, the game theory is decisions and consequences. So the signal detection theory means that there are essentially four possible outcomes in this. All right. So the observer's response is shown here. Or not. The observer's response is shown here. The observer can either say yes, all right, and if it's sorry, let's try this again. If the observer says yes, and there was a signal present, we call that a hit. Okay, because the person answered correctly. Okay. Now, if on the other hand the observer says yes, and yet there was no signal, we call that a false alarm. If the observer says no, and there was a signal present, we call that a miss. And if there was not a signal present and the observer said no, then we call that a correct rejection. So there are four possible outcomes. All right. Now, what does this all mean? Well, this is, again, perception versus sensation. All right. Essentially, if you have very lax criteria, in other words, you kind of tune stuff out all the time. What that means is that you're going to have lots of false alarms, all right, and very few misses. Okay. If you have lax criteria, then you're going to have very lots of false alarms, but very few misses, because you're going to say, actually, I got that backwards. It's strong criteria. All right. You're going to say yes a lot, but you're going to be wrong a lot. All right. And so you're going to have, and you're not going to say no very much, but you, and you won't be wrong there. So very few misses, lots of false alarms, and very few misses. On the other hand, if your criteria is quite lax, then you're going to have very few false alarms because you're not going to raise the alarm. You're not going to perceive something unless it's really there. With strict criteria, with lax criteria, you're going to have few false alarms, but lots and lots of misses. All right. And so that is what we call signal detection theory. Now, that is the end of the first of two videos on the physical versus the psychological world. And I hope you learned something.